Hi everyone, welcome back. Let's understand the basics of a complex number in this video and the three forms in which you can express a complex number. So let's see. Now a complex number is represented by the letter Z. So Z is equal to x plus IY is the most basic form where x represents the real part and y represents the imaginary part. Now since I is the imaginary number, therefore y becomes the imaginary part. So for example, 3 plus 2i, if you have a complex number in this form, then 3 represents the real part and 2 is the imaginary part. So this form is known as the Cartesian form. Now next let's understand the concepts of modulus and argument. So let's consider a point P with the coordinates x and y in the xy plane. So its distance from origin on the x-axis is x units and on the y-axis is y units. Now let the distance of this point from the origin be r units and the angle that this segment OP makes with the x-axis, let that be theta. Okay, so as we can see in the triangle OPM, it is a right angle triangle. So by Pythagoras theorem, we'll have r square is equal to x square plus y square. So therefore r is equal to square root of x square plus y square. So r is known as the modulus. Similarly, tan theta will be sin theta upon cos theta. So sin theta, as you know, is opposite side upon hypotenuse and cos theta is adjacent side upon hypotenuse. So that is y upon r upon x upon r, which is y upon x. So theta will be tan inverse of y upon x and theta is known as the argument. Let's now understand how to express a complex number in the polar form. So if we consider the same diagram, we'll have cos theta is equal to x upon r and sin theta was y upon r. So therefore x will be r into cos theta and y will be r into sin theta. So therefore if we substitute these values in the Cartesian form of x plus iy, we get z is equal to r cos theta plus I into r sin theta. So that gives us z is equal to r into cos theta plus I sin theta. So this becomes our polar form. Now the third form is the exponential form. Now e, which is also known as the Euler's number, we can write it as e raised to I theta is equal to cos theta plus I sin theta. So if we substitute this value of cos theta plus I sin theta into the polar form, we'll have z is equal to r into e raised to I theta, and this gives us the exponential form of a complex number. Okay, so let's solve one example to better understand all the concepts that we just looked at. So we have to find the modulus and argument of 1 plus I root 3 raised to 16 upon root 3 minus I raised to 17. Now let us assume that the numerator is represented by z1 and the denominator by z2. So if you observe both the terms, you'll notice that they are expressed in the Cartesian form. So let's first start with the numerator. So let z1 be equal to 1 plus I root 3. So that gives us x is equal to 1 and y is equal to root 3. So to find the modulus r, we'll have to calculate square root of 1 square plus root 3 the whole square. So that gives us r is equal to 2. Similarly, the argument of the numerator will be theta is equal to tan inverse of root 3 upon 1. So tan inverse of root 3 is pi by 3. So that gives us theta is equal to pi by 3. Now whenever we are solving such question, it is always easier when you express the terms in the exponential form. So 1 plus I root 3 then can be written to as equal to r into e raised to I theta. So r is 2 and theta is pi by 3. So that will be 2 into e raised to I pi by 3. So now our numerator was 1 plus I root 3 raised to 16. So that is 2 raised to 16 into e raised to I into 16 pi by 3. So this is our equation 1. Now similarly, solving our denominator, we'll have x is root 3 and y is minus 1. So our r will be square root of 3 plus 1, which is equal to 2, and theta will be tan inverse of minus 1 upon root 3, which is minus pi by 6. The value of theta you can also calculate on the calculator, so that you will directly get the answer. So therefore root 3 minus I the whole raised to 17 is equal to 2 raised to 17 into e raised to minus I into 17 pi by 6, and that is our equation 2. So now our question will become 2 raised to 16 into e raised to I 16 pi by 3 upon 2 raised to 17 into e raised to minus I 17 pi by 6. So if we combine all the exponential terms together, we'll have half into e raised to I 49 pi by 6. So if you compare this with the exponential form, which was z is equal to r into e raised to I theta, we'll have the modulus as half and the argument as 49 pi by 6. Okay guys, so that's it for today. Hope you liked this video and found it helpful. Do stay tuned to catch my upcoming videos, and I'll see you guys later.